Okay, so here we have three word problems. You've actually seen these before. The objective here is to just make sure that we understand like the different types of equations that are represented by word problems here. So I'm going to go ahead and write the equation for all three. Mary babysits at $12 per hour. She also works as a tutor for $7 per hour. She wants to make more than $56. So they're giving me a total here, so I know I'm in standard form. So 12x plus 7y more than, it's an inequality, this is more than 56. Okay. So Jose spent $36 at the mall. He bought gloves for $4 and scarves for $5 each. Again, it's giving me a total. This is standard form. 36 equals, again, it's equals because it's not an inequality more than, less than, at most, that kind of thing. 4x plus 5y. And then Johnny got $5 for his birthday and made $2 a week for doing chores. So this is telling me right here that there's no total. So my output's my total. This is my y-intercept. Okay, so this is slope-intercept. This is standard. And this is a standard form inequality. Okay, so what you would do now is graph each one. This one would be easy to graph, right? You start at 0, 5, and you go up 2 over 1. Here, what you would do is you would turn it into slope-intercept form. 36 equals 4x minus 5y. I need to solve for y. Minus 4x minus 4x. 36 minus 4x equals 5y. Divide by 5, divide by 5. This doesn't go in evenly. So you get 36 over 5 minus 4 over 5x equals y. So, again, a little bit harder to graph. Probably don't graph that one. Sorry, guys. And then here, same thing. 12x plus 7y is greater than 56. Minus 12x minus 12x. 7y is greater than negative 12x plus 56. Divide by 7. Divide by 7. Y is greater than negative 12 over 7x plus 8. I would graph that. Once you graph it, write down a solution. Here I might graph this one on Desmos because it comes out unevenly. Find a solution point, and you actually make an interpretation of the solution just like you've done in your project. What does that point mean on this line? And once you've done that, then I can look at it. The answers are going to vary here. So what I'm trying to do here is I'm trying to match this inequality just like we did the other one. Again, Tashai said that she wanted to work with a lot of inequalities in systems today. So first of all, I'm looking at all my lines. All of my lines are exactly the same. So my intercepts are the same, my slopes are the same, just the solution set is different. So I'm going to actually have to do all the work on this one, unlike the last one where we were able to eliminate a lot of them. So I need to turn them into slope-intercept form. This one's tricky. The y is over here. In order to get it alone, I just need to add 1 to both sides. 2x plus 1 is greater than or equal to y. I can rewrite that. Y gets the butt. 2x plus 1. So y is less than 2x plus 1. So the shading from the 2x plus 1 line needs to go down. So my y-intercept line of 1, my shading is going down. A works. My y-intercept of 1, shading is below. B works. My y-intercept of 1. Oh. Actually, this shading is above. Sorry, that doesn't work. Again, I make mistakes. This shading's below. This shading's below. Y-intercept of 1, that shading's below. So A doesn't work. Gotta do the next one. Again, you see that there's this negative coefficient here. So don't make assumptions until you've actually solved it out. This happens on Arduino. So this shading for the -5 y-intercept line is going to be above. So my -5 line, my shading is above here. My shading is above here. My shading. Huh? Oh, it should be -2. I'm sorry, I'm making a few mistakes this morning. It's very, very early. So my -2 line, my shading is going to be above. So here, it's not above. It doesn't work. So it's not B. Here it is above. Here it's not above. So the answer is C. This one, again, because all the shaded regions are so different, I could pick a point from each shaded region and substitute that point in for both of these x's and y's and see if they work. That actually might be an easier one for this type of problem where all the graphs look the same but the shaded regions are different. Again, more systems of inequalities. That was the big thing Tashai and you guys talked about yesterday. So here it's asking for the quadrant of the possible solutions. A quadrant, this is a section of a graph. And the solution is when the both shadings overlap. So I'm going to have to graph this by hand. So the first thing I can do is turn them into slope-intercept form or graph by hand. The second thing I can do is just think about the quadrants and actually take a point from each quadrant and plug it in and see if that works. I'm going to graph these. I don't have graphing paper at home, so I'm going to go ahead and use Desmos to graph them, and you can just check your work there. You have that packet of graph paper. So I'm going to go ahead and show my work so you guys don't have to watch me do this for the 4th time. So here's my work to turn them into slope-intercept form before I graph. I notice that both of the y-intercepts here end up being 2. That is going to be really helpful, I think, if you're having problems graphing, understanding like which quadrants are going to have the solution set. They're both less than, so that helps paint a picture of I have 2 positive lines and then it's a less than, so like even if I'm having trouble, I can assume that it's probably quadrant 1, quadrant is 2, 3, and 4, that it's definitely not quadrant. That actually I can't assume anything at this point. Sorry guys, I'm going to graph this on Desmos and show you the picture. So if I look here at Desmos at what I graphed, it looks exactly like my sketch did. My purple is my solution set, right? It's where the red and the blue overlap, and it's in each quadrant. It's barely here in quadrant 2, kind of like I drew, but it is there, so all 4 quadrants work. So the answer is all 4 quadrants. D. Last one, question 10. Which graph shows the linear inequality? Oh my god, again, we should be beasts at this. They all have a y-intercept of 1. And they all have an x-intercept of -2. So again, I'm going to need to do a little bit more work. Again, the 1 line is solid on all of them. So it's just about the shading. My solid line has shading below. Yes, no. My solid line has shading below. No, it doesn't. Yes, it does. My dotted line has shading above. It does here. It does not here. A is my answer.